All right, guys, this is homework number 3, answer key. So let's take a look at question number 1. The graph above shows a function f of x. The function f of x doesn't have a nice rule, but based on the points shown, you can still answer the following questions. So it looks like for all of these problems, we have the same structure. We've got f and then a number inside the parentheses, which is usually x. So because this is x, we can go to x on the graph, x equals 10 on the graph, which is right here, and then find the point on the graph that matches up with that. So when x is 10, the output is 2, because we have the point 10, 2 here. So this is the y-coordinate. For the next one, when we want to find f of 4, we go to x equals 4 on the graph. So it looks like the highest point on the graph, the maximum value, and the output value is going to be 8 because the coordinates are 4 for x, 8 for y. I think you guys can do the rest, C, D, and E, so I'm not going to go over those. Let's take a look at problem number 2. It looks like a similar one. The graph above shows a function f of x. The function f of x doesn't have a nice rule, just like the last one, but based on the points shown, you can still answer the following questions. So I think this one's a little bit trickier because we have to be really focused on whether things are the input or the output. So since 5 is inside the parentheses, 5 is going to be the input value for this function. Because it's the input, it's going to be the x-coordinate. So let's find when x is 5. So 1, 2, 3, 4, 5. And it looks like the point on the graph is here at 5, -9. So when 5 is the input, -9 is the output. Determine A if f of 3 equals A. So I'm going to change colors so it's clear to see. 3 is inside the parentheses, so that must mean that 3 is the x value, the input, and A is the corresponding y value, the output. So you go to 3 on the x-axis, and the coordinates of that point are 3, 5. So it must be that the output value, A, equals 5. Changing colors again. So determine B if f of B equals 3. I feel like this is my favorite question where I switch the old input to becoming the output now. So because 3 is the output now, 3 is going to be the y value, B will be the x value. So since we know 3 is the y value, we go to 3 on the y-axis, and then we try to figure out which point has a 3 for y. It looks like it's this one. So the coordinates of this point are -4, 3. So in order to get an output of 3, B has to be -4. Changing colors again. For what value of A does f of A equal -2? So A is the input value, x, it's unknown. That means -2 is the output value, that's y. So we go to -2 on the y-axis. It looks like in order to get to -2, we have the point -8, -2. So it must be that in this problem, A is -8. Different A than here, right? 2 A's are different. All right, and out part E is me being really sneaky or clever, trying to be at least. So for what value of x does f of x equal x? And you might think this is a typo, but it's not a typo. So reading this one's a little bit tricky. So f of x equals x. So it looks like we're trying to find what number do we plug in for x so that we get the same number for y. So we want the input and the output to both be x or to both be the same value. So let's see, are there any points where the input and output are the same? So the input equals the output. And there's only a couple points to check here. It looks like this one might have that property. So let's see, 1, 2, 3, 4, 5, 6. And since the output value is the same value, we get that it must be x equals 6 where this occurs. So when you see a problem like this, it can be a little hard to decipher, but because we want the input and the output to be the same, this is the only place where that occurs. All right, for problem number 3, which equation is represented by the graph below? So usually when I do multiple choice problems, I avoid looking at the choices until I take a look at the problem and solve some stuff. So let's try to find the equation of this graph. So it's a linear graph, so I know it's going to be in the format y equals mx plus b. So because I zoomed in, the pen is pretty messy, but maybe I can do a little bit about that. So for b, b is the y-intercept. So let's see, we hit the y-axis at -5. Oops, that's not a 5. At -5. And then all we have to do to complete the equation is figure out what the slope is. So we don't have any endpoints like we did in the graphs in class. So I can pick any point on the graph that's on the grid. So starting off at the y-intercept, it looks like the next point that's on the grid is right here. So thinking about the graphical version of slope, delta x over delta y. Oops, that's delta y, right? So delta y and delta x. We can use those to figure out our slope. So our slope is delta y over delta x. Here our slope is down 2 over 1. So our slope is m equals negative 2 over 1, which can be simplified to just negative 2. So the equation of our line is this. All right, let's zoom back out and take a look at the choices. Oh man, that is none of the choices for the problem. So I don't think we made a mistake. But what I noticed is that none of these multiple choices options are actually in the form y equals mx plus b. So maybe what we can do is we can convert them to the correct form and see which one matches. So solving this one for y, you get 2y plus x equals 10. Subtract x on both sides. 2y equals negative x plus 10. Divide by 2 on both sides. I get y equals, and remember when we add negative x, it really means negative 1x, so we get negative 1/2 x when we do this division. And when we do the second part of the division, 10 over 2 is 5. So neither part is right. The slope and the y-intercept are wrong, so this one's not correct. So just using my instincts, maybe. Actually, it's because I've done the problem before. I think choice 4 looks like it's correct, so before I circle it, maybe I should actually check that out. So in pink now, I'm going to take a look at choice 4. So I'm going to bring this one over rather than go through all the choices. So you have 2y equals negative 4x minus 10. I divide by 2 to isolate y on both sides. I get y equals negative 4 over 2 is negative 2x. Negative 10 over 2 is negative 5. And it looks like it matches what we found from before. So this is the equation of that line. I know I didn't check choices 2 and 3, but if you do check them, you'll find that neither of those choices actually matches the equation that we found. Next up, determine the slope of a line passing through the points negative 7, 2 and 5, negative 4. So I don't have any graph paper in front of me, so it looks like this is one of the problems where I want to use my slope formula to algebraically find the slope of the line. So our slope formula, just like we talked about in class today, is slope, for some reason m, right, even though it's not in the word slope, m equals y2 minus y1 over x2 minus x1. So just matching things up from the points, I'll just use the same color, sorry. Y of the second coordinate is that one, y of the first coordinate is this one, x of the second coordinate is 5, x of the first coordinate is negative 7. So substituting these things into my equation, I find that m is equal to negative 4 minus 2 divided by x2, 5 minus x1, negative 7. So doing some arithmetic, negative 4 minus 2 is negative, oh sorry, I'm looking at the bottom. I'm talking about the wrong thing. Negative 4 minus 2 is negative 6. 5 minus a minus, that becomes plus 7. 5 plus 7 is 12. So m is equal to, if you reduce it by 6 on top and bottom, negative 1/2. All right. Now we've got this kind of daunting looking word problem, but I think hopefully the stuff we learned in class with the visual patterns can be applied here. So let's see, a production company likes the work of 2 editors equally, but must make a decision on which to hire. The first editor charges an initial fee of $3,000 to work on the project, and $20 per hour for each hour that she spends editing the project. So it looks like for our first editor, they start off with an initial fee of $3,000, and they make $20 per hour for each hour. For the second editor, let's underline the key information just like we did. The second editor charges an initial fee of $2,000 to work on the project, and $35 per hour for each hour that he spends working on the project. So answer each of the following questions. Write equations for C1, I'll just circle that in blue because this is the blue editor, and C2, this is the pink editor, the second one. The cost of hiring each editor dependent on the number of hours T that they can work. So because each editor has an hourly fee, depending on how many hours they work, they're going to have a different cost of hiring them. So for the first editor, C1 of T, this should remind us a lot of the visual pattern circle problem that we looked at. Instead of starting with 6 circles like we did in our classwork today, our editor starts off with a cost of $3,000. If they work 1 hour, sorry, this is a parenthesis for T. If they work 1 hour, they make an extra $20. If they work 2 hours, they'll make $3,000 initially plus 20 times 2. If they work 3 hours, they'll make 20 times 3 because it's $20 for every hour. And so forth. So if it's 10 hours, they'll make 20 times 10. In general, though, we want to come up with an equation for if they work T hours. So they make $3,000 to start, $20 an hour times T hours. Similarly, our pink editor is also a linear equation because he makes $35 every hour. So his cost of hiring is always going to increase by $35, a constant rate of change for every hour that he works. I'm going to point to this one too because it's also constant. So the cost of hiring the second hour editor as a function of time t is that editor starts with $2,000, and for every hour they work, they make $35, so 35 times the number of hours that they work. Great, cool. And I'm actually going to leave the rest for you guys to figure out. So hopefully this was a good check, and I'll see you in class.